Hello class, today we're going to be covering Unit 1, Chapter 1, Section 3, Distance and Midpoints. Our lesson objectives today are to find the distance between 2 points and find the midpoint of a segment. You will see a little review in here from algebra from last year, so keep your eyes open. Alright, distance and midpoints. We're going to start off by talking about the distance between 2 points, and that is the length of the segment connecting the 2 points. Alright, so let's first talk about distance on a number line. And so we're going to use absolute value of x2 minus x1. Absolute value you've seen before. We're going to review it a little bit. When we talk about x2 and x1, those are referring to our 2 points we're going to be using. And in that case, order is not important. All right, and don't forget, as we're going through this lesson, if we're going too fast, feel free to pause or rewind and go back and take the time to get everything written and understand through it. All right, so let's go ahead and look at some examples here. The first one says find AC. So we're going to be looking at point A and point C. Again, it doesn't matter which one is our x2 and which one's our x1. So we're going to take the absolute value of -5, our A, minus our C, which is 0. So -5 minus 0 is -5. And remember, absolute value is its distance from 0. So whether we're at -5 or +5, we are still 5 points away from our 0. So the absolute value of -5 is going to be 5. So our distance of AC is 5. Let's do BD together. So looking for BD, B is at -2 and D is at 2. So again, it doesn't matter our order. So -2 minus 2 and absolute value around that. And -2 minus 2 gives us absolute value of -4, and the absolute value of -4 is 4. Okay, so for tomorrow, please go ahead and finish problem 3, which is finding AD. All right, so now let's go on and talk about midpoint of a segment. The midpoint of a segment is the point halfway between 2 points. We did talk about in previous lesson betweenness of it is, and that was between 2 points was another point, and it didn't matter if it was halfway or anywhere in the middle. Here, midpoint has to be exactly halfway. And we have a formula for this one, and this is x1 plus x2 and divide by 2. So let's look at what's the midpoint of FH. So here's our F, here's our H. Again, it doesn't matter which one is x1 and which is x2. So our midpoint of FH, we're going to do -3 plus 5, and we're going to divide by 2. -3 plus 5 gives us 2 over 2, and 2 divided by 2 is 1. So our midpoint for this is at 1. All right, I want you to take the time to finish up problem 5, finding the midpoint of GH for tomorrow. All right, so let's use our midpoint formula and ideas for these next few problems. So 6 says find B given A is the midpoint of BT. So if we know A is the midpoint of BT, we know that BA is going to be equal to AT. So we can find B by setting 2B plus 3 equal to 11. Now all we're going to go do is solve for our B, and then that'll give us our solution. So we are going to -3 to both sides. That cancels, so we have 2B equals 8. Divide both sides by 2, canceled there. So our B equals 4, So let's go back and make sure that we answered our question, and it said find B, so we have found our solution. So moving on, now here, this problem 7 says find the measure of PQ if Q is the midpoint of PR. So again, Q is the midpoint, so PQ is going to be equal to QR. So we can set 14 plus 5y equal to 9y minus 2. Now we see that there's y's in there, so we're going to have to solve for y and then plug it back in to find our PQ. So go ahead, and I want you to solve for y and find the measure of PQ for tomorrow. All right, so next we're going to look at our coordinate plane. So first we ask about what are the coordinates of the following points. So remember, when we're talking coordinates, we want x and a y. X is how many it is left or right, and y is up and down. So first we're going to find g. G, if we count g over, it's over 7, and since it's to the left, it's negative 7, and it is down 1. Our f is 1, negative 1, and our h is 6, 5. All right, so midpoint formula on a coordinate plane is similar but slightly different than our midpoint of a segment. Here we're going to be talking about both x and y, and so our formula for our x's is going to be x1 plus x2 divided by 2, and we're going to use the same thing for our y's, except we're going to have y1 plus y2 divided by 2. All right, so let's go ahead and do problem 8 together, and then I'll have you guys do 9 for tomorrow. So what's the midpoint of FH? So we start off, we're going to just remind ourselves that our F was 1, negative 1, and our H was 6, 5. So we're going to start with our X's, and so we have 1 plus 6 over 2. And then our y's is going to be negative 1 plus 5 over 2. If you're not sure where I got those numbers from, take a pause, go back, look at the formula, and look at our points. All right, so if we take 1 plus 6, that gives us 7. We still have our divide by 2. And then our y's, negative 1 plus 5 gives us 4, and then we have our divide by 2. So if we come up with our midpoint, we are going to take 7 divided by 2, so we get 3.5. 4 divided by 2 is 2. And so our midpoint for FH is over 3.5. So 1, 2, 3, and then just a little bit, and then up 2. So 1, 2, so here is our midpoint, and if we take a look at our line through FH, that looks like a great midpoint. So go ahead and take a look at problem 9 for tomorrow. All right, last part for today, we're going to talk about is distance between points on a coordinate plane. This should look familiar. We did cover this with algebra. So take a moment. It says given 2 points, x1 and y1, and x2 and y2, the distance between the points can be found by the formula d equals the square root of x squared minus x1 squared plus y2 minus y1 squared. Okay, that should look familiar. We did talk about last year that it doesn't matter which of our points are x1, y1, and x2, y2, as long as you stick with the 1's together and the 2's together. So what's the difference from points F to point H? So these are exact same coordinates from the previous slide. So our F was at 1, negative 1, and our H is at 6, 5. So we're going to go ahead and do the distance formula with this. So our distance formula says d equals the square root of, now we're going to plug in, and again, if you don't know where I'm getting these numbers from, hit pause, go back and look. Okay, 6 minus 1 squared plus 5 minus negative 1 squared. Now pay attention, minus a negative, we can double slash so that it becomes a positive. So now our distance becomes the square root of 5 squared plus 6 squared. Okay, I'm going to just head up over here so I have a little more space. So we still are continuing with our square root. 5 squared is 25 plus 6 squared is 36 25 plus 36 gives us 61, and the square root of 61, I'm going to round, so I'm going to use my approximately, is 7.8. So my distance between point F and H is going to be 7.8. So go ahead and finish up problem 11 for tomorrow. Find the distance between point G to point F, and we'll pick up with that.